Hi, in this lesson we are going to make a walking light or colorful light using ESP32 microcontroller and 74HC595 chip. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. And here's the documentation page for this project 2.4. If you come to the documentation page of SunFounder under for Arduino user 2.4, it says microchip 74HC595. This is a chip that can be used as a counter or shift register or a counter. And here are a list of components that you need for this project. We need ESP32 module, and then extension board, camera extension board, breadboard, jumper wires, resistor, LED, and the chip itself. And here is the schematic diagram. So the chip is wired to 3.3 volts, and we just use 3 pins, SHCP and STCP, 2 pins, and then the S pin 25, 26, and 27. And then we have these 8 LEDs, and for each LED we have 220 ohm resistor to just have the voltage of 3.3 volts divided. So we use these LEDs, and I'm going to show you the wiring when I reach to the wiring section. At the bottom of the page we have the code. If you're using cloud, you can connect it from here, or we are using, and also there is some explanation of the code here as well. Here is the data sheet for 74. All of this X474C585 8-bit shift register with 3 state output registers. There are different versions of it available. We have CDIP and PDIP. These are the version, and also there are surface mount type. So the main features are here. We have 8-bit serial in, parallel out. What it means is we are inputting serial information from single 1, 2, or 3 line with different requirement. An 8-pin on the same time will be controlled in parallel, so we will see that. The operating voltage is 2 volts to 6 volts, and we are using it with 3.3 volts. So low power consumption 80 microampere. Input current for each pin is 1 microampere. And this is a block diagram of the chip, or functional block diagram. You will find it in this shape, or you can find it in this shape. This is a shape that we have, and for us these are important to know that which pin is which. Pins are very important. From this notch you can see from here, from 1 to 8 is on one side, and then 9 to 16, but here it starts, QA is in here, and then B, C, D, E, F, G, and H. These are the name of the output pins. The timing diagram. And here is a typical application that we are using for our purpose. We are using them with some resistor here. Because of the higher voltage, they put higher value resistor. For us, it will be 220 ohm. It will be fine. And we are going to set some of these pins. We are just using 3 pins. The rest, we need to have them either connected to positive or negative. Okay, so let's start our wiring. On the breadboard, on the top, blue line is our negative, and at the bottom, blue is also our negative. So we have to understand that first. And this red on this side, at the top of the breadboard, this will be our negative, and this blue will be our negative as shown in here. And then this red line, the line that has red color, this will be all our 3.3 volts, and this side as well, this will be our 3.3 volts. To do that, first we will connect a red wire from this red to this point. Doesn't matter where, just insert one red and then connect it to the red on this side. This way we have whatever we connect here, it will be connected there. As I've explained it in the video that I introduced the breadboard, this line is all connected. The red on this side and blue on the other side. 2 separate wires are here. So once we connect it from there to here, the same way we will have on both sides. And let's get a black wire from the blue, connect it to the blue in here. Now we got these 2 wires connected as shown there. Then we are going to place our chip. This is our chip, and pay attention that I'm holding it with this notch here. So this dot shows pin number 1, and it goes 1, 2, 3 up to 8, and then we have 9 up to 16. And in the picture also you do not see it much, but this is the one. So we can have enough space maybe in here. If you cannot insert it, just bend the pins a little. And it can be inserted like this. Now let's do these pins, which are very important. The right pin, the last pin is VCC. We will connect it to the positive. Just grab a red wire from here. We're just connecting it to positive. So this is now connected. Get another wire. So the 4th pin from the top, from this side, we will connect it to the ground. I'm getting some blue wire because I do not have. So 1, 2, 3, 4. The 4th one doesn't matter. This line is all the same. Connected to the ground like that. And then from this side, the 2nd wire will be connected to positive. From this side, 1, 2, 2nd wire connected to the positive. When I say positive, that's the pin. This portion is done, and we will start. These 3 pins will be at the end. We are doing these pins. Now let's go for the LEDs. So we'll get the LEDs the same way: red, yellow, green, blue, and then red, yellow, green, blue. And here I got them all. The long pin is this pin on this side because that side is ground. So we connect the short pin there and then the long pin here. Now in the picture it is shown like that, but this is not easy from here, and I'm trying to connect it. Let's bend the longer pin a little like this. So this now can be inserted easily. And here I've inserted all the LEDs, and I left here 2 lines in between each LED. As you can see, 1, 2, empty, and then 2, 2, 1, 2, up to the end. If for some reason you could not follow on the breadboard, this is the wiring. So the pins are mentioned, this is the pin number, and these are the pin names. And we are connecting from Q0 to Q7, which is 8 pin. We are connecting them to the resistors, and which are connected to the LED. But these are the pin names, but the pin number is pin 1, 2, 3, and so the first one is Q0 is 15. So we start from 15, and then we come to 1, 2, 3 up to 7. And here, as you can see, pin 13 is connected to the ground, and pin 8 is connected to the ground, like that, if I follow. And then let's see, the 3.3 volts is connected to pin 10, and it is connected to pin 16. So pin 10, pin 16. And the same way as I mentioned, and here pin 13 and pin 8 is connected. You see, pin 8 and then 13 is connected to the ground. And look at the wiring here. This is pin 8, it's connected to the ground. This blue is ground. And then, as I said, 9, 10, 11, 12, 13. This 13 is also connected to the ground. So we are following exactly how it is in here. And then for the pin 11, pin 12, and pin 14 is connected to 26, 27, and 25 of our microcontroller, or ESP32. Now let's insert 220 ohm resistor for each LED, and we are going to connect it to one of these pins. For example, for yellow, we will connect it here or there, any of these, and then the other side of a resistor should be connected to this side. Let's do it for the red first. I'm connecting it like that, and so it has been connected. Now I'm going to connect the rest. Let's connect this wire from the chip from the right side. This is the pin 8 to the ground. So this is pin 1, and that's 8, from 8 to the ground, which we forgot. Like that. Now for the wiring, because they have used different colors, let's follow a convention for ourselves. What I'm going to do is, for each color, I'm going to get the same color. For red, yellow, green, blue, and then red, yellow, green, blue. We will use the same wire, so we are not making a mistake. So I'm going to start from red. This red is going to pin 15, so that's our LED 0. So get a red wire, and the resistor that goes to this red is in here, and I'm going to pin 15. Connected. Then yellow goes to pin 1. The rest are in order. We are not making any mistake here. Yellow goes to pin 1. So get yellow, and from the resistor that is connected to the yellow, it goes to pin 1. Like that. Anywhere you can connect it in the same line is okay. So then green, the next one goes to the next pin 2, and then blue. You see this green goes there, and then blue goes to the third one. Now That's done. Let's go back again to the red, yellow, green, blue. Red, the next hole, red, yellow, green, and then blue. So our wiring have been completed now on this portion. For these signal pins, we connect 25, 26, and 27. So we start from pin 11 to 26. And here, this is pin 9, 10, 11. It goes to 26. I'm getting a blue. That is the third pin from the right. And this goes to pin 26. So that is pin 26. Then goes 12 to 27, pin 12. And here, the next pin to 27. And I'm connecting it to pin 27 here. And then pin 14 goes to 25. And here pin 14 goes to 25. Fourteen is the third pin. So because the last pin is 16, 15, 14, that's empty pin. And this goes to 25, which is on this side. All three wires have been connected. We will connect positive. We should not forget these two pins, the main power supply. So positive just connected anywhere along this red and connected to 3.3 volts. This pin towards the USB is 3.3 volts. And then connect a black wire anywhere on along the blue line. So that's our ground. And we are connecting it to ground. Ground is the second pin here, and also we have multiple grounds. The wiring is now completed. Now let's open the project by clicking on File, Open. From the left, click on your download, and then go ESP32 Starter Kit Main. C, and then codes, and then here you will see 2.4 74HC595. Click, and as you can see, this was not inside the folder, but anyways, click and open it. And if there is a warning or something, just accept it. It will create a new folder, and here is the code. Let me explain it. We are defining ST CP pin and HC CP pin. So these are the two pins. And then the S pin, based on the pins, based on the data sheet, these are all integer and constant, so they will not change during the execution of the code. Here we have an array, integer array, and we have these values. When you have open and closing parentheses, you can have multiple value assigned to this variable, and we have a value at the beginning, B. This B means binary, so we are allowed to have only 0 and 1, and then if you put B, and these are all the values up to here. These refers to the LED, so all LEDs are off, and here the first one is on, and then the second, and then the third one, and then the fourth one. So 0 means off and 1 means on. And then we reach here 7, and then this is now, so we have 3 and 3, 6, 7, and that's 8. So all LEDs will be on. Now inside the setup, these 3 pins that we have defined them using pen mode as output, output, output. So these are all outputs we are sending, and this code which is inside the setup will run only once. Now inside the loop from here to here, so this for loop runs and gets each value from here and sends it to the chip. So it gets first this one, and then it gets first this value, and then this value, and so forth. So this is 0, position 1, position 2, 3, up to position 7. Now this for loop, it says int num equals 0. We have learned about defining a variable. This variable is defined with 0, and here it says if num is smaller than 10. This is supposed to be 8. If it is 8, it will go only up to 8, and we will see what problem this creates. So, and then it uses digital write, and then it sets the STCP pin to low, and after that it sends the value. It says shift out. Shift out is a function, so shift out gets the value of the pin. This is the DS pin and this pin, and then MSD, so MSD first, and then from the data array it gets the num. The num is 0, and next time it goes and it becomes 1, 2, 3. Every time it changes, it gets the value from here. So we are sending this value with MSB first to with these two with a shift out, and then digital write. Then this pin which was low, now we are making it high. As soon as we make it high, it will shift one value, and then we have this 1000 millisecond delay, and next time num it comes here and num become 1, and then 1 is smaller than 10. It continues 2, 3, 4 up to 10. When 10 is not smaller than 10, this loop exits, and then we come here, and then the main loop comes back and then runs this for loop. So we have for loop inside the main loop. My ESP32 is already connected to computer, and make sure the board is selected. If not, click on Tool, Board, and come to ESP32 and select ESP32 dev module. After that, we have to select the port. Right click on the start menu, go to device manager. Let's see what port it is. And here under the port we have shown you before. Now again, mine shows port 8. Yours might be different. Whatever it is, just remember it, because if you connect multiple devices, you will have different numbers. And here click on Tool and then COM port. If you see multiple of this, select the one that you saw under the device manager. So 8 is selected, and now everything is ready. Let's just upload the code. The code. Now I'm waiting for the code to be uploaded, and as soon as the upload will finish, you will see that LEDs will turn on like that, and at the end we have 3 lights on, and it goes off. Now to change the timing in the code, because we have 1000 millisecond delay, you can make it, for example, 300 millisecond, 1/3 of the time. So these lights will turn on very quickly. I clicked on upload, it will interrupt it, and as soon as this compile reaches to 100%, you will see that this will turn on and off, will run very quickly like that. So now this is much faster. So you can play with this sketch and have fun. And here I changed the time to 100 milliseconds, and the speed has changed like this. Now if you pay attention here, we have 8 LEDs, and we have 8 state that turns on, but there is one more. When it turns off, that's another state. So we have total 9 states. Now let's change this to 8. 8 means it goes less than 8, so up to 7. And I'm uploading the code. Now pay attention, it should go up to here and then stop. Each is for 1 second on, it will take 1 second. So it did not go up to here because this is 1, so we should have 8, not 7 inside the loop. So we could have here equal sign up to 8 and then upload the code. Let's see. Now it worked properly, and that extra blank which was inside the code have been disappeared. That's why we have to set it to smaller than 8, and here if you pay attention we have 1 and up to 8, and then we have one state which is all 0. So we should have equal or greater or less than 8, or if you prefer that we can put even less than 9, which is 8. It will work the same way. Now I am updating the code. We had it up to here, then I went in reverse. So I reduced 1 and then 1 more, and I created this ladder. This way now it will turn off like that. It goes to 1 and at the end. Now because from here to here we had 8, I have added 9, 10, 11, 12, 13, 14, 15, not 16. So here let's set this to 16, which goes from 0 to 15, and upload the code. Let's see it. I'm just waiting for the code to get uploaded. It's almost 10, 20 to 30%, and now it will interrupt and the code will start working. Now let's see. Now it turns off from that point back. Let me change the timing so it can go a little faster, and let's make it 300 and upload the code. So I uploaded the code now with 300. It's just interrupting now. Let's make it 200 and upload the code. Oh, by the way, this is not turning on. Oh, yes, it works. So now the code is being uploaded with 200. Now it's interrupted. It just halts it when the code is finished. Now it's much faster. Now here is the code that for the walking light I've set here the LED 0, and then 1, 2, 3. Only one of them at a time is on, and as a result the LED will walk and it will reach 8. After that it will turn off all 0, and then it goes one by one to the right until it reaches to to the maximum, and the loop will continue like that. The rest of the code has not been changed, and inside the loop, here I have put here 16, 8 and 8, 16 elements here. And this is a demonstration for the walking light. The light just walks back and forth, but we can also change it if you want just to walk and then start again and start again. Very simple, as I've explained it.